3D Printing Today, show number 430. Advanced Tuning. Installing Orbitor version 2s on the tool changer. Open builds.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, it does not matter. We cover it all. My name's Andy Cohen, and I'm here at Mr. Whitney Powder.
How you doing, Andy?
Doing pretty good. So, we've talked a little bit about printing in space, 3D printing.
Yeah, this was a while ago. We actually interviewed some guys down at a trade show.
Yeah, that was a long time ago. I talked with them at CES and Maker fairs, and we've talked about articles, and it was all the FDM stuff. Well, Now we're hearing there are multiple efforts, one through NASA and one through ESA, the European Space Agency, where they're looking at evaluating metal 3D printing, in particular the DED version of metal 3D printing in freefall. So
this is basically using a laser to melt wire. Right,
I think so.
Yeah, I think that's that technology.
It could be wire, or it could be. I've heard of another technology where it's like a
powder,
a fed powder.
Yeah, I don't think they want the powder in 0G. I don't think that would work out well.
Yeah, you've got to have that Bowden effect to control the movement of the material. I don't know how you do. Well, you wouldn't be using gravity anyway, but that's another topic of discussion.
No, right.
But what's interesting is that yet again we're seeing stories about what's happening up in the ISS, the International Space Station. We're getting it like third hand, and I gotta say, I find that a little bit disturbing that all of our tax money goes into this national hobby called space, manned space, and
this is speaking from a man who used to work in that industry.
Yeah, I was part of the early space station project, and there are a lot of projects that I emotionally support, wholeheartedly support in space. Manned flight, not so much. These days, my opinion on manned flight is diminished. And but what I find a little bit distressing is it's not that easy to get the stories, the actual reports of what has been done in the space station. There's no resource that says here are the articles, and they should be open sourced, available to the public. And I don't think they are. At least the 3D printing stuff, I'm not seeing anywhere.
Yeah, I haven't looked extensively for it, but it doesn't really come out and hit you in the face. So.
No, and I think what we would need, if any NASA people are listening, is when they did that thing in the picture, the 3D printing industry did this article on it. We have the reference in our notes. And in that link, you're going to see photographs, and they talk about the two projects. And what's nice about one of the projects, they're actually comparing ground-based versus in orbit quality, which I don't think they did with FDM as well. But there's a photograph of the FDM machine that they flew, at least the one that was up there made by the ESA side. And you know what? There's no resource in there to study the image of the hot end, and that's what we need, you guys.
Right.
There should be a camera right on that hot end, and when you're in 0G, there should be a series of object shapes and geometries and tests that we see the effect of zero gravity on how it's deposited, how the liquid material comes out, how it extrudes, how it fuses to the bottom layer. Nothing. All they do is they print it and they compare the end result. So it doesn't do anything for us at all. It's a bit of a waste of money, frankly.
Yeah, and it's interesting to see this the photograph of this, because it appears to be using 3mm filament. and the filament is just an absolute mess. I mean, it's like the worst bird's nest of the spool you can imagine.
It's like somebody said, let's put this machine down, light it up. Oh, put a spool in there. Let's fix that spool, shove it in there, and put a whole bunch of test prints around it.
Yep.
Yeah. Oh, well.
I'm kind of looking at it like, I hope they didn't waste our taxpayer money trying to print with their filament in that condition.
Well, I imagine they wasted ESA's money, not NASA's. NASA's money was a different machine that didn't look as good as that machine, quite frankly.
No, well.
So it goes.
That machine does look pretty cool, though.
It does. Yeah, I guess.
Except for the filament.
Yeah. Well, thanks, NASA. If you're listening, you can, and if I'm completely wrong here,
send us a link.
Get mad at me and email us and yell at me and tell me how wrong I am. I'd like that.
Don't get mad. Just get even by sending us the links.
And then we can talk about the great research you guys pulled off. Anyway, what's coming up on our show this week, Whitney?
Let's see. We start out talking about advanced tuning.
And we're going to discuss installing an Orbitor V2 now on the tool changer.
And then we take a look at open builds.
Let's do it. So in working with the Orbiters and the Nimbles on the tool changer, as well as my Duet clone, I've been tuning and tweaking and having some fun trying to make my prints look better and better and better. When I pulled the Nimbles off the tool changer, I had forgotten because it's been 2 years. The Nimbles do have limitations, and in particular, their biggest limitation because of the drive cable is the settings for how quickly it could react to an immediate stopper or direction change. Now, that setting in some firmwares is referred to as jerk.
Okay.
In the Duet world, that's referred to as what it is. It's called, I think it's time to react or time to the minimum or maximum time, and it's related to acceleration. So jerk and acceleration are coupled. Now let's talk about acceleration first. Acceleration is how you set how quickly the extruder comes up to speed and the distance for it to come up to speed versus slow down before it stops and changes direction.
Right.
So acceleration's working when you run your 3D printer, and if acceleration's fairly substantial, it'll go.
Right. The thing to remember about acceleration is that it only really works over long distances, that if you're going really short distances and changing your direction very quickly, you don't actually have time to accelerate.
Yes.
So this becomes very apparent when you're working with a really big printer, and you can tell I can remember turning up my acceleration and saying, okay, my print should be happening faster. And your print isn't going to happen any faster unless you're making a very large print where acceleration really matters. Yeah,
acceleration. You need to tweak acceleration when you're going faster and it's bigger, and you don't want effects. You don't want artifacts like ringing and overshoots, which are really easy to get. If you're going full tilt and slamming on the brakes, you're going to get a messy print.
Yeah.
Now, jerk is similar to acceleration, and they work together. And if one's kind of high, the other one's got to be kind of low. And so tuning them can get kind of tricky. And I have found in my experience that once you've got it good for that machine at the speeds that you print, you don't muck with it. You
just leave it well enough alone.
You're not going to get any better. You can't tweak one without it affecting the other. And that's just the way it is. But there's a third thing, advanced tuning thing that you could do, which I think is really relevant, and unfortunately, I couldn't do it with the Nimbles. I had to turn it off because the Nimble drive cables do not do well with jerk, and this is tied to jerk. It's called pressure advance or linear advance. I think it's linear advance in Marlin, pressure advance in Duet. I think it's linear advance in Clipper. Now, in Marlin, it's two 2 factors. In the RepRap world, it's RepRap firmware, it's 1. And in Clipper, I think it's quite a bit more on it, more than 2. And Clipper, it's pretty complex.
It's being done under PID control on Clipper.
Right. Clipper, well, I mean, complexity is a two-edged sword. It means you get more control, but it also makes it more complicated. With the RepRap firmware, it's obviously simpler, but that means you've got less control. And remember, these 3 tuning things are all kind of tied together. You can't change one without it affecting the other. So what you're finding is the best mix of the 3 of them. Now, what pressure and linear advance actually does is, if you can imagine, you take a tube of toothpaste or a tube of glue, right? And you squeeze a little bit, and you get this pressure in this viscous liquid pushing the stuff out an orifice. Okay. Now that pressure, once you've compressed it, it takes time for the stuff to come out of the hole. And if you don't release that pressure, it'll continue going out that hole when you don't want it to. So the glue will go all over the place.
Right. You won't get a linear extrusion of it.
Right.
Yeah.
So if you're printing a square box and your extruder's traveling along at its speed, and as your acceleration kicks in and it starts to slow down, your extruder may not slow down at the rate that you need it to stop the stuff from oozing out too quickly. Because, as you're moving, it's going at a certain rate.
Right.
And it's pressing down that filament into the nozzle. When it gets to that point where it's got to stop, you're not going to be, unless you tell it to do something, it's going to put more plastic in that corner than you want it to.
But see, that's tricky because as you're decelerating, right, then you have to be extruding faster, right? Because you're moving.
Well, the pressure's there. So what you need to do is, before you start decelerating, the pressure has to back off a little bit sooner.
Right, because you're going to be spending more time at any given location, so you will want to be depositing the plastic at a slower rate.
Yes.
Okay,
yes.
That makes sense.
Yeah, the idea is to get the rate. It's kind of like if you're squishing the glue tube, you want to pull back on that squish and reverse that squish a little, right about the time when you've got enough glue.
At just the right rate, right?
Yeah.
Until you get to the corner, but then you need to fill the corner with just the right amount
at that speed.
Right.
And of
course, at that point when you're at the corner, you are now stationary for a moment.
Right. Now.
So yeah, it's remarkable that any of this works.
Yeah, and you got to remember, it depends upon the distance between your drive gear that's pushing the filament and where the melted filament is coming out the hot end. So if you're using a Bowden tube, your settings for pressure advance are way higher than if you're using a direct drive.
Right, because the Bowden tube, you've got this massive spring in the middle, basically.
Now you'd think, well, why would I need that with direct drive? Many times you don't. I never needed it on my Rep 2. My Rep 2's worked fine without any pressure advance.
Or the level of printing we were doing at the time and the level of quality that was acceptable at the time didn't require it.
I do my test cubes, and my test cubes, the corners are perfect in my Rep 2s and in the Clone R1. And why? Because the distance between the hobbed gear and the hot ends are kind of close. Whereas on my tool changer with the new Orbitors, now that distance is, I'm holding it, what is that, about 30, 40 millimeters? That's enough. That's enough to get some elasticity.
60 millimeters there, yeah.
You think so?
2 inches?
Yeah, maybe. Yeah. So there's enough there to get a little bit of compression and a little bit stretching of that filament that's going in and out of that tube.
Sure.
So I still need to do pressure advance. And now that I'm no longer using the nimbles, I can turn pressure advance on again and get nice fine tuning. Now, here's a reality check, though. When you do these tunings, these 3 factors, it's extremely dependent upon your speed. So if you're changing your speeds, you have to be changing these tunings. It'll drive you crazy, because to get to tune linear advance, first you have to know your speed. You make yourself a hollow cube with no top, and you in your code in our show notes, I'll have the links that'll help you find this at the RepRap firmware duet board. There's code you can use in a couple different slicers as macros, and it will change the linear advance for sections of the print as you move up in Z. And then you can see the effect physically on the cube and pick the one that looks the best. And then you take that one and then you change the settings so it's the range within that one to get even a finer refinement of what your linear advance should be for that printer for that speed. But here's the thing with all these things. If you're downloading stuff from Thingiverse and printing, if you're getting customers coming in and throwing all sorts of prints at you, all different types of stuff, and you're printing them once or twice, you can't touch this stuff. You've got to get your optimal for that printer for your print speed and never touch it.
Right.
On the other hand, if you're printing hundreds or thousands of one part,
you can afford to tune it.
This is what you need to tune. You've got to go in there and do the advanced settings and all your other settings to get the optimal print. And then once you got it, you're good to go. So it all depends upon your use cases and how you use your 3D printer.
Cool.
So since I was so pleased with how the Orbitor 1.5 was working on my tool changer, I figured, okay, let's retire all the other Nimbles, get them all off, and let's update the 1.5 and get all 4 brand new V2s. So I went shopping, I went looking around, and a friend of ours, Luke, on our Google groups, suggested I go to this one seller on AliExpress called Blue Rolls. And so I took up his suggestion, and I found a version 2.0 Orbiter made by LDO. They're usually stepper motor producers, and they're pretty well known. And they actually produced the body of the Orbiter, so I thought, okay, that's probably a safe bet.
That's the version that Philistruder is selling, so I'd imagine it's probably pretty good.
And I noticed as I'm looking at the order, I had like hours before they shut down for the holiday.
Oh, is this Chinese New Year?
Yeah, so I went ahead.
Good luck.
I went ahead and did the order, and I'm thinking, I ain't going to see that for a long
China
time.
Post is going to shut down too.
So a couple days go by, and I get a note that says, you may see your order in 80 days. Then another post, you may see your order in 40 days. And then another post, your order has shipped.
Oh, okay.
And then another post, your order's gone through customs and it's on its way to your post office.
Nice.
And then another post, it's sitting at your post office. Go get it. And then finally...
Yeah, I love the way you get that one.
2 weeks after I ordered it, it's at my front door. So I got it pretty quick. That's pretty fast for coming from China. Chances are it was someplace much closer. I would bet.
I don't know. I've had the exact opposite experience. I've had them ship things that they said were shipping from their U.S. warehouse that clearly came from China and took coming from China speeds. So
anyway, I got the V2s, opened them up, and I'm like, wow, this is like quality. I haven't seen this level of workmanship since I got the feeders from Bondtech. I mean, this is quality stuff. And it says on the box that the drive gears were made by Bondtech, which I wonder about because I've got 5 Bondtech feeders. None of them look like these gears.
This may be a newer version.
I don't know.
Or, I mean, I would not be too surprised if they were licensing that from Bondtech.
So, the first thing that's really different about these is the size of the planetary gear depth. These are much shallower, so the motor does not stick out nearly as far. I think it's more than an inch difference. These are much lighter. They're still using a planetary gear setup. It's the same size motor as the motor used in my Orbitor 1.5. But one thing I've learned is these small steppers, they're getting the current right is a tricky thing. And as I was a bit surprised to find that I had to up the current by almost 3 times to get it to stop stuttering.
You mean triple the current?
Yeah, I went from 340 to 900 milliamps.
Uh-huh.
Okay, so mounting it was easy. The mounts are available on Thingiverse. They work brilliantly. You do have to press in an insert. You have to melt and press in inserts, brass inserts for the screws. But I've done that so many times on this tool changer that it's, trivial for me to do that. If you've never done it before, get yourself a box of them and a bunch of plastic holes to play with and experiment and learn how to do it.
Print yourself some practice holes.
Yeah, each of us have our own way of doing it. You like to use a drill press.
If you can get at it with a drill press, it totally depends on. If it's attached to the machine, that's not practical.
Yeah, these you couldn't use with a drill press. Yeah. I like to use a really long 3 millimeter bolt, and I put onto the thread of the 3 millimeter bolt a nut. I put a washer against that, and I put the bushing. I thread that to the washer, and I use the washer to get my level, so I know I'm right on spot. Sure. And I chamfer the corners of the hole so that I get centered before I go in. And I use a little torch to heat it all up, and it worked pretty well. My first one, I put the mounts on. It was a little trickier than I expected, but within a half an hour, mounted pretty easily. I love the way it uses the OEM parking frames, those little pieces. They're made of metal, and they ride on the pins, the parking space pins on the tool changer. Okay. So I get precise parking. I wasn't getting that with the Nimbles because I had to 3D print that part for the Nimbles, and that was really challenging. Well, all of that problem is gone. So I've got all three of the V2s on there. I still have the 1.5, and I'm testing, and we'll see how it goes. I'll be putting up examples on our Google group, but it's not that hard to do, and I'm pretty impressed. I'm getting really, really good quality. Yeah. One thing that I do notice is that the current is affecting the pattern in the plastic, in the extruded plastic. And this kind of may be a clue to solving problems that we've seen over the years many times. You remember that company that was in San Leandro? I forget the name. No, I forgot the name of their printer. They disappeared a long time ago. They had one of the largest bed wooden frame printers. Drawing a blank. They were
using like a NEMA 11 or something?
They used a small stepper on their extruder on their second generation printer, and they got a pattern in the plastic. And now I know why.
It could be.
It's the current. If your current, you've got to get the current. It's that particular motor. It's not every motor is going to be different.
Right.
You got to get just the right current, or you'll get a little bit of
vibration.
A little vibration frequency in there, and that shows up in the plastic.
Interesting.
Yeah. So I tweaked it until each motor, I got the minimal pattern. You could just barely see it in light. If you hold the light a certain way, you may see it. Other than that, I'm getting Bondtech quality extrusion.
Oh, that's good. That's interesting because NEMA 17s are, I guess, they're just a lot more forgiving. Because I used to tune them by just listening to them and tuning them, tuning the current down until they stop screaming. Yeah, and that worked pretty well.
Yeah, the problem with these little motors is if you tune them down, they don't have enough torque.
Right.
And so you've got to tune them up to get the torque, and then there's the issue of heat. If you get too much heat, the heat will travel through the planetary gears to the area where the filament is, and you'll get melting. So have to be careful with that. So Whitney, are you familiar with openbuilds.com?
Yeah, I've used a lot of stuff from their part store. It's it's a good place to get aluminum extrusions and linear guides and the little wheels and stuff.
Yeah, I've looked for their parts as well, thanks to your suggestion. But what I didn't realize is if you dig a little deeper and hit the builds selection on the menu or the projects selection, you're going to find that this is a community of folks that develop and build computer-controlled things of all types, and they basically just broadcast post what they've done.
Yeah.
Folks can then join in and do one as well.
Sure.
And basically people work together in a collaborative way to develop these computer-controlled devices, such as 3D printers.
3D printers, CNC machines, laser cutters. Yeah, a lot of good information out there. Yeah, I've been watching. I've never posted anything to it, but I've sort of been aware of it and watched it for years since it's been growing. And yeah, it's coming along nicely.
I would say this is probably one of the best resources for building something from scratch. If you're going to build something from scratch, it's probably a good idea to start here and explore, become part of the community, and learn what's going on there. I don't usually build things from scratch, to be honest. I usually build things from kits, or I get them pre-sourced. But this really is from scratch. And you'll see some amazing things in there. I have some ideas that I may jump in there with, but that's a different topic of discussion. But I wanted to bring up and discuss this community and make people aware of it, because one of our members on our Google group, whose handle is "What is your email ID?" That was kind of interesting. Yeah. Wanted to mention that one of the most well-known and most prolific people on OpenBuilds, the OpenBuilds forums and the projects, a fellow named Keith Davis, is no longer participating because of an illness, and he suffered a stroke a few years ago, and he's dealing with paralysis, and we just wanted to put it out there to thank him for the great work he's done. And he's greatly missed. And I just wanted to mention that on the show. So thanks, Keith. We appreciated you. And hey, thanks to What Is Your Email ID for posting us and telling us about this. Oh boy, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed. To all of our very supportive listeners, thank you all out there for your support on Patreon. Thank you for your positive reviews wherever those can be made. And thanks for listening. We do it for you. We do it for fun. We do it for positive reviews, too. Let's see. We got a thing of the week. You got the thing of the week this week.
Yes, we do.
What is it?
It's called Los Comodino Triste. And it comes to us from Robbie985, otherwise known as Roberto Pinotti from Italy. And this is some fine Italian design. It's like scomodino is basically means like we would call a dresser, I guess. And it's basically this little, relatively small dresser that sits on a shelf, but you've got to, you just got to look at the picture of it to understand. It means the sad dresser. And you can just tell by looking at this dresser that it is sad.
Yeah.
Either somebody has put something in it a long time ago and forgotten about it and no longer opens and closes its drawers, or it wasn't printed very well and its drawers are all jammed. I'm not sure what it's sad about, but you can just tell from this dresser that it is sad. Yeah. It's really, really cute little design. It reminds me of, we were talking before the show about that we did a Dr. Seuss dresser years ago on the show, and this is sort of the same thing. It's a very expressive furniture in a way that would be very difficult to manufacture without 3D printing.
Yeah, and it would be a great thing for a young person to have on their real dresser, as for like jewelry.
Yeah, you could use it for, things. I think it's pretty small, but you could use it, well, I mean, depending on how big you want to print it, I guess. Yeah. But anyway, it is thing number 5324148, Los Comodino Triste.
Yeah, and by the way, we didn't mention that's on Thingiverse.
On Thingiverse.
Yes. If you've got a tip, a question, or a candidate thing of the week, please don't hesitate. Send us an email.
Send it to info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
And yet again, we invite you to join our Google group. Go to Google and search 3D Printing Tips and Tricks. And when you get there, if you want to post, you have to hit that join button and give them an email that you can get access to. Again, we don't recommend using your regular personal emails for things like this. Make up an email on Gmail or Yahoo and use that one, and just use it for this and nothing else. Let's see. We do have a show next week.
Oh, we do.
Show number 431.
We talk about how to tell if a 3D printer is selling well.
we're going to be tuning retraction.
And then you give us an update on the Orbiter.
Well, I guess that's it.
Great. Thanks for listening.